Alright, welcome back to the optional session on information content, entropy, cross-entropy, and KL divergence. We've seen these three. Remember, information content of a distribution is inversely proportional to the probability distribution. Yeah? That means that if I have a high probability of something about to happen, then the information content is low, because it's almost certain. That's why they're inversely proportional. And then we defined the entropy, and the entropy is nothing more than the expected value for the information content. So it's the average information produced by a stochastic process. And then we define cross-entropy, and here we have two distributions. We have P, that is the true distribution, and Q is a distribution that we use to approximate P, right? So this is given by this formula, and it basically gives a distance between two probabilities. So we can actually use this to measure if two probabilities are the same or not. And that's exactly what KL divergence does. KL stands for Kullback-Leibler, the two guys that introduced this. And this is how we note it. P, then two parallel lines Q, and it's a similarity metric for distributions. I would say in our case P and Q. So let's derive this formula. We start from the formula for entropy. So what we're gonna do here is, first of all, we're gonna change this minus to a plus sign. To a plus sign. And this one we inverse that. Is like this. Alright? Now what I'm gonna do is I'm going to multiply by Q, and I'm going to divide by Q, right? So let me put the brackets here. So then we have equal P times the log of Q over P. So I take this one and this one, and then minus the log over Q. Alright? So I put the minus here because I want to get the Q on top. Here we go. So that's equal to P log Q over P, minus the sum over P and then log Q. Alright? Minus the sum P log Q. Okay? So this is KL divergence. Sorry, no, it's this one. Now this is the formula for cross entropy. So this is cross entropy of P and Q. And this we're gonna call minus the KL divergence. And basically we're gonna use that minus to put here, so you swap. So the P comes on top. Alright? So, and this is still entropy. So basically what you have is that your cross entropy of your two distributions P and Q equals my entropy, and then I bring this to the other side, plus KL divergence of P and Q. All right? So So basically, you want this to be as small as possible. Because if this is small, your probability P and Q will be very close to each other. Yeah? Alright, so just remember, KL divergence is a metric to show the similarity of probability distributions. Alright, so we have KL divergence of these two distributions is equal of the sum, right, of P log P over Q with the negative sign. Yeah? So that is my formula for KL divergence. And if P and Q are the same, this is the log of 1, which is 0. So your KL is 0.